Guys, am I audible?
Yes.
Ah, So, current. How much charge flow in a given time? Remember, time rate is important. Time rate means in denominator you have time. Whenever you hear the term rate, it means you take time in the denominator. Okay. So, current will be charge upon time. Direction of current, Sarah, what will be the direction of current?
The flow of electrons.
Flow, no, opposite to flow of electron.
Yes, opposite of the flow of electrons.
Yes. It is scalar quantity, though it have direction as well as magnitude, but it do not follow. So it do not follow law of vector addition. Okay, Jordan, what is this law of vector addition? What does it mean? What is special about this?
Um, Basically, when you add up the directions, it'll be in the direction of whatever the majority is in. I don't remember how to explain it properly, so
The simplest way, guys, if you take, let's take this is A, this is B. This is A amount of current, this is B amount of current. In case of scalar quantity, if you calculate total, then your total value will be equal to A plus B, simple algebraic addition. Okay. If you have vector addition, if you have vector addition, then and you want to calculate total, then it will be A square plus B square under root. Understood? That is the biggest difference. In case of vector, you take square addition and then under root. Correct? But in case of scalar, simple addition. Got it? Any doubt? Example, if you take potential, if you take work done, these are the scalar quantity. You simply add them. Kinetic energy, potential energy, you simply add them. But when you take vector quantity like electric field, you were considering the direction. Any doubt? Next, because it is not a vector, that's why angle between the two wire does not matter. Okay? Angle between the wire does not matter at all. Means whatever angle you take, same thing happen in case of potential also. Doesn't matter what angle you take, because it is a scalar quantity, it won't be affected. Chandana, when we take current carrier in case of solid conductor, what will be the current carrier?
Sir, ions.
Valence electron. Ion in case of solutions, aqueous solution like positive and
Yes.
negative ion. And in gas, in case of gas, ion only electron or ion. But remember, most of gases are insulator of electricity. If you take very high temperature, very high potential difference, example, thunderstorm, current can pass through the gases, but only in very high potential. Understood? Nothing else is important from here. Drift velocity, yes, we get question from the drift velocity. So first you take thermal velocity of individual particle. Example, you have 100 particle in a system. You have 100 particle in a system. Okay. These 100 particle will vibrate and they will be responsible for the output, final velocity. Okay. What will you do in this situation? Your average thermal velocity, you will take total of all. First particle, second particle, 1,000 particle, and then you divide by the number of particle. It is random thermal velocity will be always zero, and you will use this for your numerical purpose. The average thermal velocity is zero of the electron. Why? They are randomly moving in any direction, so there is no net velocity. But if you take individual particle, example one electron, this one electron move in a particular direction like this. Electron move in a particular direction like this. It drift, it move with some speed, and this velocity is the drift velocity. Okay? This velocity is drift velocity. What is the value? Very, very less. 10 raised to power minus 4. Very less. 10 raised to power minus 4 means if you take in zero point 0.1 millimeter in 1 second, negligible. The net movement of the electron is very less. We already did this in the last chapter. Electric field is potential and length. Anvita, is this the correct formula? E is equal to V by L. Anvita, is this the correct formula?
I'm not sure.
What is the real formula from the last chapter in the form of velocity, potential and distance? Minus dv by dx. Yes or no?
Yes.
Minus dv by dx. Here, it is the potential difference dv. And even in this case, it is potential difference. See, V is potential difference, not potential. V is potential difference, not potential. And because difference in the length is L, that's why this is correct formula. But direction will be still positive. It is not taking plus potential difference or negative potential difference. It's just taking potential difference. So it's like magnitude form of potential. So this is the derivation of this. Okay. So if you calculate force, you know force is equal to Pratikya, what is the formula of force with relation to electric field and charge? Force is equal to QE. And because we are taking for electron, so instead of Q, you will write minus electron. Got it? Then you know force is also equal to mass into acceleration. So mass will go to other side. This is the acceleration value. If you calculate final velocity by the electron, how will you calculate? Initial velocity plus A vector and tau 1. Sarah, what is this tau 1?
So average time.
Yes, time. This tau is time. We will use term relaxation time. Like it is the time taken between the two collision. Example, one particle collide here. After that, it collide here. So time taken between this journey is the relaxation time. Electron is relaxed, not colliding. But final velocity will be this. If you take average final velocity, this will be the drift velocity. Okay. So if you say ki what is the drift velocity in this case, you take average final velocity of all the electrons. Average final velocity of all the electron is the drift velocity. If you apply same formula, you know initial velocity is zero. We did here. Average thermal initial velocity was zero. So initial velocity will be zero. Take the final value. So can we say your final velocity will be equal to acceleration and tau? What is tau? Relaxation time. What is tau? Relaxation time. Okay. What is the tau? Relaxation time. How much time is taken to collide between the two particles? Very less. Chandana, what was the average drift velocity in case of electron?
So 10 power 4.
Minus 4. We said very less. Relaxation time is also very less. Relaxation time is also very less. Understood? Relaxation time is also very less. So you can calculate your velocity will be equal to A. Tau is the relaxation time. If you know this, then you know your drift velocity is equal to acceleration into tau, and your acceleration value is QE by m. Acceleration time is QE by m into tau. Done. Okay. QE by m. Why? Because same method. Mass into acceleration is equal to force is equal to QE. You can calculate acceleration time and put value here. Hmm. What is the negative sign meaning here in case of electron? Negative side indicate that drift velocity direction will be opposite to the electric field direction. And in doubt, guys, should I explain this again?
No, sir.
No, sir.
Anybody? Anvita,
No, sir.
Pratigya, Pratigya, are you there? Chandana?
No, sir.
Okay. Relaxation time, as we already discussed, it is the time interval between two successive collision. If there is one collision, second collision, time gap between these two collision will be tau, relaxation time. So what will be this value? This is also important in your mean free path of your kinetic theory of gas. In kinetic theory of gas, you calculate mean free path. What is the mean free path? Mean free path is the distance between two collision. Example, here at A point you have collision, at B point you have collision. Distance between these 2 points will be known as mean free path, and time taken to between this collision is tau. Understood, guys?
Yes, sir.
Yes, sir.
Yeah. Barinder, you are also there. I didn't mention you, right? Oh, sorry for that. So, mobility. Barinder, do you remember in one of the semiconductor question, we were talking about mobility. Ki if you take current in case of electron and current in case of holes, where you will have more mobility? Like where will be more current? It was related to mobility. Do you remember, Barinder?
Yes.
Huh. It was the last question, I guess, question number 19, if I'm not wrong. So, there is a call. हेलो लाइट ही भाई आता है दोबारा ये अपना ये पासे भजे थे मैंने देखे थे मैं एक मिनट ना ना आ रही है ना उरे इन्वर्टर में चार्ज में ला रहे हैं मैं उरे हूँ बैठक में हाँ so which one will be more who will tell me Jordan
Yes, sir.
which one will be more mobility of electron or mobility of hole
Mobility of electron will be more.
why
Smaller in size, it is affected by electric field more compared to the holes.
but electric field
I
is not involved in this process
It's not, but then like mobility of electron will be more, sir. And on top of that, I remember you telling us last year that holes do not move. It's just it because of the electron movement looks like as if holes move when you're learning NNP type.
yes this is true
So So that's why I said the mobility of electrons is more, sir.
Yes, mobility of electron is more, but you have to tell me reason.
Smaller mass.
Yeah, so mobility will be explained here. Just give me a minute.
So can you show the screen?
So I was talking about mobility, ability to move, as the name suggests, ability to move. And this ability to move is related with the drift velocity. Why? Because more mobility means more velocity while you are applying a given electric field. Eh? Yes, guys. So ability to move, mobility, when you apply electric field. So mobility is represented by nu, and this nu is the drift velocity when electric field is acting on it. You know drift velocity value is QE tau by M. Divide by electric field. Electric field cancel. Jordan, look at this. It does not depend upon the electric field. It depend upon the mass.
Yes, sir.
Any heavy thing will move slow, right? Logically also, that makes sense. More charge, more moving ability. Correct? More
Yes, sir.
relaxation time, more moving ability. So these are the three factors. So what is J in this case, Barinder? What is this J? This J is current density. This J is current density. It means how much current is present in a given area. How much current is present in a given area, current density. So more the current density, more will be the current, right? Because if J is more, I is more. But at the same time, it is mentioning cross section should be same. Area should be same. If area is same, current density depend upon current, right? Density will depend upon the current. Next, drift velocity is very small. We know 10 raised to power minus 4, very less. Why? Because there is a continuous collision. If there is a continuous collision, particle will not move continuously for long time. It will face another collision. Understood, guys?
Yes,
But
sir.
drift velocity, even a small amount, how much small? 10 raised to power minus 4 meter per second. Even this can produce large amount of current. How is that possible? Because of the number of electrons. You know, charge is equal to Ne, and your current is equal to charge by time. It means current will be Ne by time. Can we say current also depend upon the number of charge particles? Correct. Num Amount of current also depend upon the large number of electrons, because here you have large number of free electron in a conductor. That's why there will be more current. What will be the speed? Almost with this speed. So imagine, okay, drift velocity is very low, 10 is to power minus 4. Still, your current speed is almost near to the speed of the light. Reason? Number of electron are very, very high. Understood? And same thing is given. That's the reason how, if you just turn on the like button, like just the tap on the button, instantly bulb will glow immediately. How is that possible? Because of the speed of current is very high. And how this speed of current is very high? The moment this A particle collide with B, instantly it will go to C and then D. So continuous collision will happen. But if you don't apply electric field, what will happen? Electron will move in any random path. In absence of electric field, there won't be proper path of electron. Yes or no? Any doubt, guys?
No,
If you apply
sir.
electric field, there will be a smooth path. I'm saying smooth, not curve. Why curve? Because example, if you apply electric field, here you have positive charge for the electric field and electron is moving, then electron will move toward the positive. So path will be curve. But if you don't have any charge, even collision is random, but whatever collision will happen, it will happen in the straight line because there is no positive or negative charge to attract or repel. Understood? What will be the number of free electron? Why, Anvita? Why this formula? Why? Because overall it is about the total number. If you have 1 kg gold, then we first will calculate what is the number of moles. Once you get number of moles, 1 mole contain Avogadro number of atom, or 6 into 10 is to power 23 atom. Then we'll check what is the number of electron in each atom. That is X value. Correct. D density, like is it tightly packed or loosely packed? Correct. And A atomic mass, if you have more atomic mass, heavy material, then you can accommodate less number of electrons. Make sense? Example, if you have small atom hydrogen, you can accommodate more atom in this. But if you have one gold, very big particle, what will happen? You can accommodate less number of electrons. So total number will be less because it inversely depend upon the atomic mass. Understood? We already did drift velocity. We did electric field, and this will give mobility. We are done with this. Correct? Chandana, does mobility depend upon electric field?
No, sir.
No, it does not, because electric field is not there in the formula. Next, if you want to calculate the total current, then you can use the method of the drift velocity also. How? Mobility of the electron will be drift velocity upon electric field. So, you know current you calculate is charge by time, and drift velocity, if you calculate, is the distance by time, mean free path by relaxation time tau. Correct? Mean free path relaxation time tau. So instead of this time, you can correlate with the, instead of time, you can write lambda by drift velocity. You can correlate. Make sense, guys? Okay. Next, if you have this volume AL, area into length, volume, this is the number of electron in a given system, because N is the density. What is this density? AL, and N value is total number of electron per unit volume. Volume will be cancelled. It is equal to total number of electron. Any doubt? If this is the total number of electron, charge is equal to Ne, and total number of electron is area into length into density. Remember, this is particle density, not N, like this. This N and this N are different. Okay. And now E, correct? And if you know this, then current value is charge by time. Correct? You have charge value, you have time value, then your current will be charge upon time. Charge value is area into length into number density into electron divided by time. Okay, divided by time. So N E A, what is the length by time? This part. What is this length by time? Velocity. L is length, tau is time. It will be NEAVD. Understood, guys? Should I explain this again?
Yes, sir.
I- Sure, then I will. See, we said if we want to correlate our current with the drift velocity. How to correlate them? First, we want to calculate total number of electron, because we know charge is equal to N into E. We know E value, we want to calculate N value. How to calculate in the form of density? So the simplest way is volume area into length is volume, and you take density, this n, which is equal to total number of electron per unit volume. This is written in the form of n. So can we say total number of electron will be area into length into n? Barinder, any doubt?
No, sir.
How to? If you know this, then you know the quantization of charge q is equal to Ne. N value is N A L E. Correct? Current is equal to charge upon time. What is charge value? NaLe divided by time. And length by time is velocity. Understood? Barinder?
Yes, sir.
Hmm. Anybody have doubt from this?
No, sir.
Uh, uh, this 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 is done. Remember only one thing, because you will make mistake. You will consider this n as number of electron. No, it is not number of electron. It is number of electron per unit volume. It is number of electron per unit volume. Not and this is very popular formula. I think in 2024 for sure you got this question. I'm not sure whether you got in 25. I have to check once. NEA VD, same formula. And you know this is the drift velocity formula. You can apply in the form of this current. How? NEA, and instead of drift velocity you can write this. We did already. Done. Yes or no, guys? NEA instead of VD. You know, if I recall the previous formula, force is equal to QE. Force is also equal to mass into acceleration. Your acceleration value will be equal to QE by M. And you know your drift velocity is equal to acceleration into time. Acceleration value QE by M into relaxation time. Do you remember this part?
Yes.
Yes or no? Yes. Okay. You already. Are you getting background noise now?
No, sir.
Okay, great. So you already know Ohm's law. Current flowing through a conductor depend upon the potential, or potential depend upon the current, and that's why you have V is equal to IR. You already know. I won't teach this part. We want to discuss this. You already know this is the formula of the drift velocity, and from the last chapter, you know E is equal to V by L. Correct. So instead of E, you can write this V by L. Correct. And your formula of current, that was NEA VD. So NEA, same thing. What is the drift velocity formula? E V tau by ML. Yes or no? So your current will be equal to this. Make sense, guys? NEA, NE square A tau by ML. Yes or no? Got it? Ask your question and keep writing. Today, in between, I will ask the same question. What is your next class time? 2 to 3:30, right?
Yes, sir.
Yes, sir.
Yes,
Yes, sir.
I will take on time 2 to 3:30, but I will extend this class for next half an hour. Is it okay for everyone?
Yes.
Okay, let me know if anybody have issue. So V by I, because V by I is equal to R. V value is V and I value was this. N E square N E square A tau by ML into V. V will be cancelled. It will be equal to this part. ML and E square tau. Interesting point is, one, you don't need to remember this. Second, still need ask question from this. You don't need to remember, still need ask question from this. And this formula is so lengthy, it's difficult to remember. So easy way to complete this formula is key always write, focus on this. I is equal to NEAVD. Now you should know कि drift velocity is equal to charge. This is force by mass into tau. Okay. Third formula you should know, electric field is equal to potential by length. These are the three formula. By using this, you can calculate. And fourth formula, V is equal to IR. So that is the best part. That's why people got usually good score in the current electricity. Why? Because same formulas are repeated again and again so many times कि automatically they remember formula. Okay. Next, this is not universal law. It means not every material follow this. Only substance that follow the Ohm's law is known as ohmic substance. Substance that do not follow the Ohm's law, non-ohmic substance. Okay. Example, in most of the metallic conductor, it is straight line graph. It means if you increase current, then your potential will also increase. You have theta value here. Barinder, what will be theta in this case? Tan theta. What will be tan theta value in this case? V is equal to IR is the formula, and Y is equal to MX is the another formula. Y is equal to MX plus C. Graph equation. So instead of y-axis you have V. Instead of x-axis you have I. It is starting from 0. So C value is 0. So Barinder, what will be M value? R. So tan theta will give you R. Slope will give you R value. So if next time they ask ki, you have this I and this V and there are two different angle. Uh, Pratigya, where you will have more resistance? T1 or T2? Resistance which
T1.
T1. Here, if you take R1 resistance, this you take R2 resistance, then R1 will be greater than R2. Why? Slope is more, and slope is giving you R value. Got it?
Yes, sir.
Uh, And in case, oh, this is extremely important. Anvita, tell me what is the impact if you increase temperature in case of conductor? This is extremely important concept. In case of conductor, if you increase temperature, what will be the impact on the resistance? If you increase temperature, what will be the impact on the resistance?
So resistance
Anvita,
will increase.
decrease.
Oh yeah, okay, fine, yeah.
No, increase.
So you're confusing me. I think it increases, right? And
Yes,
conductivity.
yes, it will increase. The reason being ki I always do this mistake because I want all of you to be 100% sure कि this is my reason. And the reason is कि when you increase temperature in case of conductor, they already have maximum conductivity. maximum conductance. If you increase temperature, what will happen? This electron in the conductor will start vibrating. It will create problem in the path of other electron. And when it create problem means resistance.
So conductivity decreases, no?
Yeah. If resistance increase, you know, conductance will decrease, conductivity will decrease. Sigma, conductivity decrease. Rho, resistivity increase. Sarah, we did the same topic before.
Semiconductor.
Yes, exactly semiconductor. If we did this in semiconductor, tell me what happened in case of semiconductor. If you increase temperature,
So resistance will decrease,
resistance will decrease,
conductivity will increase,
conductivity will increase, resistivity
re- decreases.
decrease. Okay, ulta. Why? Because here you don't have all the free electron. If you increase temperature, there will be more free electron. More free electron, more current. Okay? More free electron, more current. So these concepts are extremely important. In case of insulator, what will happen, Chandana? If you increase temperature in case of insulator,
So resistance
resistance
decreases.
decrease, same like semiconductor, but impact in case of insulator will be minimum. Why? Because there is huge energy gap between valence electron and conduction electron, valence band and conduction band. So you require a lot of energy. Example, if you increase temperature from 25 to 30 degrees Celsius, no impact will be there in case of insulator. Example, at 20 degrees Celsius, wood furniture do not conduct current. If you increase temperature to 40 degrees Celsius, still it won't pass current. It means even at high temperature, it is insulator only. So there is very less impact in case of insulator. Okay, very less impact in case of insulator. So you can calculate resistance by this way. And if there is more resistance, then temperature will be more. Why? Because in case of this conductor, if you increase temperature, resistance also increase. This was the concept. Very important concept. But there are some material that do not follow Ohm's law. Such are known as non-ohmic material. Non-ohmic material. Example, gas, rectifier like semiconductor device, thermionic wall, transistor. All these are semiconductor device. Okay. And formula will be same. Like you can correlate with the help of tan theta slope and everything will be same. But it will not be exact in the straight line. It will not be same how it happened in the straight line. Then you already know what is resistance. Obstruction to the flow of current is resistance, which is equal to V by I. SI unit ohm or volt ampere. Dimension I won't do. Length. This is important. The resistance directly depend upon the length, inversely depend upon the area. If you combine both, it directly depend upon length, inversely depend upon the area. And if you remove proportionality constant, it will be rho. Okay, it will be rho. Jordan, can you explain this concept of resistance?
So basically, the concept of resistance is a mobility of electrons, the amount of resistance which the conductor or whatever body provides
Mm.
to the flow of electrons is called resistance.
Yeah, example, I gave you example of the city or your place always. Ki if you want to go to your place to 10 kilometer, you will face less resistance. But if you travel 1000 kilometer, more resistance, more problem. So more length, more problem. If you pass through window, less area, then you will face more problem. But if you increase area, then resistance will be less. So inversely proportional to area. When you remove the proportionality constant, it depends upon the medium also, material also. Example, if you take copper and zinc, both are metal, but in case of copper, current will be more. In case of zinc, it will be less. So it depends upon the nature of material along with the length and area. That's why rho, resistivity. Correct? Resistivity is also known as a specific resistance. This is related more with the, you can say, nature of material. It depends upon the mostly nature of material. Which nature are you using? See, what I did in this situation, I wanted to calculate R. How will I do? I wrote the same formula. I is equal to N E A V D. N E A V D. Then I wrote VD formula. Correct. Instead of electric field, I wrote potential by length. And when you calculated V by I, you got this ml by Ne square A tau. No need to remember formula, just two step and you can solve. If this is the situation, how to calculate rho? You know, R is equal to rho L by A. It means rho will be equal to R A by L. Correct? L will be cancelled, A will be cancelled. And same thing is written here. Resistivity is the internal property of the substance. So it depends upon the nature of material. It does not depend on the size like length, area, and all the stuff. Where you will have minimum resistivity, silver, because silver is a very good conductor. Silver is a very good conductor. And if you see resistivity of the quartz is maximum, means it is a best insulator, you can say. So silver best conductor, and this sequence is important. In case of insulator, your resistivity will be maximum. In case of conductor, resistivity will be minimum. Semiconductor in between, but alloy have more than semiconductor or conductor. Correct? Any doubt? If you calculate resistivity, what is the resistivity? It depends upon the temperature, but not on the size or shape. Remember, it depends upon the temperature, but not on the size or shape. So your resistivity at T temperature, this is resistivity at T temperature. And this is the resistivity in the initial stage, initial value, starting conductivity. Okay. And as I already mentioned this point, okay, you will see if you increase temperature in case of conductor, resistivity will increase. This is for conductor. This is for conductor. If you increase temperature, your resistance increase, your resistivity increase. Whenever resistance increase, resistivity follow the same pattern. Ah, is it tough to understand, guys? Whatever I taught as of now.
Yes, sir.
Huh? It is tough to understand.
It's not tough. I just said you understood.
Okay. I was asking, is it tough to understand
Oh, no, it's not tough, sir.
for anybody? Anvita,
No, sir, no, sir.
next, bubbly bada taya.
Yes.
Understood? Parinder Kaur,
Yes, sir.
Chandana Rastogi,
Yes, sir, understood.
Sarah Anthony.
Understood, sir.
Sarah, is your spelling like name spelling correct? SARAH.
Yes, sir.
Okay. Because as of now, I have heard mostly SARA. So if you increase impurity, then resistivity increase. It depend upon the nature of material. Impurity in case of metal. Again, we are talking all this stuff about the metal because metal already had maximum conductance. Whatever you do after that, it will decrease only. Correct. Then if you take the magnetic field also increase resistivity for all the metal. Why? Because same rule. You already have maximum value. Whatever you do, it can reduce only. It cannot increase. Make sense? Whether it is impurity, whether it is temperature, whether it is magnetic field. These are the few exception. Different type of magnetic field and type of material, diamagnetic, paramagnetic, ferromagnetic, because of that. Next, for this selenium, cadmium, sulfide, in this case, it inversely depend upon the intensity of light. It means if you increase intensity, if you increase intensity, then current will be more. If current is more, resistivity will be less. Logically, it should be like that only. Okay. If intensity I, intensity increase, then your current will also increase. If current increase, your resistivity will decrease. Correct? Resistivity decrease. We already did this. The resistivity directly depend upon the mass. If you increase mass, your resistivity will be more. Example, if you take only 10 gram of material, it will create less resistance. But if you take 10 kg material, then there are more number of particles, they will create more resistance. It depend upon the mass. And people, trust me, will forget this part, mass. Why? Because they feel ki, okay, whenever we talk about the current stuff, it is related to the charge. What is the relation with the mass? But it is related. Conductivity is opposite of resistivity. Like how you have conductivity opposite of resistivity, same. We have conductance opposite to Barinder. Conductance opposite to reciprocal to yeah.
Conductivity.
Conductance is reciprocal of resistance. Okay. So this conductance C is equal to 1 by R and unit is Simon or mho. Ohm opposite mho. Okay, ohm opposite mho. Huh. Pratigya, if you have theta here, what will be the slope value? I by V. I and V relation. What will be slope value in this case? I want to teach you how to read graph. So this question. Slope will be
V by I.
1 by R or C. How do we know? You know, uh, in this case, I by V, uh, it will be y axis by x axis. No? Correct, Pratigya? I by V or C conductance or 1 by R. How do I know? Because first we will write equation mx plus c. In y-axis you have current. In x-axis you have V. And because it start from 0, so c value will be 0. Then it will be m. You know V is equal to IR. Can we say I will be equal to V by R? Can we also say I is like Y? V is equal to like X. Can we say 1 by R will be equal to like M? No. Yes or no प्रतिज्ञा बढ़त्या one by R or C. What is C? Conductance or I by D. This reading the graph is extremely important in your full physics. Reading graph. सुबह कोई नहीं थकावट हो रही है तो सोचे क्या दिक्कत है काम लगी रहो सब इसका के पूजा करा दो हैं और क्या के पूजा करा गए हैं गुरुनाथ टेवा दे इसके दो एक तरह का कड़ा फोन मिलेगी वो तो जमा सुन दे माचे हैं